KURINJI Senior Secondary School, CBSE, Namakkal.
Successful result producing school in state every year.
Administered by the Board of Directors with over 35 years of experience in the teaching field.
Special attention on art, craft, music, dance, silambam, yoga, skating and karate.
Focus on Hindi Sabha and Spell Bee Olympiad exams.
Smart class for effective and innovative learning and well-furnished library.
Solitary importance on sports and games in state and national level.
WhatsApp facilities to know activities of students and school inside the campus.
Free bus for LKG to 8th standard.
Free, hygienic and nutritious food.
NEET, JEE, IIT coaching experts from Rajasthan and Andhra Pradesh along with our effective teachers.
Admission registration for classes LKG to +2.
KURINJI Educational Institution, Kavetipatti, Namakkal. Admission in progress. CBSE, KG to 12, contact 9025895176. Metric 6 to 12, contact 9344567484. For online admission, log on to www.kurinjischoolnkl.in.
Next continuation to the last class. In this class we are going to discuss about frictional force. Friction and what are the types of friction, what are the laws of friction, the factors on which frictional force depends. Okay. So about all these things we are going to discuss now. Okay. So if you see just for 1 minute what we discussed in the last class, there we discussed common forces in mechanics. Common forces in mechanics. So in mechanics, what are the common forces? So basically gravitational force and electrical forces, right? So what is gravitational force and what is electrical forces? We already knew from our lower classes onwards. Okay, right. So if you want to go in deep, gravitational force is because of the nature and the matter. Okay, basically. And electrical force means the force exists between either two opposite charges or similar charges, right? Okay. So in continuation to that class, in this class we are going to concentrate on friction. What is the definition of friction? What are the types of friction? What are the laws of friction? And what are the factors on which frictional force depends? Right. So before going to enter into the subject, just you imagine yourself what is meant by friction, right? Generally it is a force, it is a frictional force. For example, tensional force, what we are calling it as tension. Similarly, frictional force, what we are calling it as friction. Okay, right. But we have to understand the scenario or the situation where the frictional force arises, right? So the simple example I will tell you regarding the frictional force, right? When we are walking on surface of earth, when we are walking on surface of earth without slippers, right? When we are walking on surface of earth without slippers, what will happen? We are able to walk comfortably. There is no disturbance, we can walk comfortably, right? Suppose if you are walking on surface of ice, what will happen? You may walk, but you can't walk comfortably because there are chances for skidding, for slipping when you are walking on surface of ice. So the same person, the bottom of the foot is same because the same person is going to walk on surface of earth and the same person is going to walk on surface of ice, right? When the same person is walking, when he is walking on surface of earth, he is feeling comfort, but when he is walking on surface of earth, he is not feeling comfort. So what may be the difference? The person is same means the bottom of the foot is same, but where is the difference? The surface on which he is walking is different. In one aspect it is surface of earth, in another aspect it is surface of ice. Okay, right. So surface of ice means it is smooth generally for our personal experience, right? It is smooth. Surface of earth means it is rough. You can say like that. Okay, what is this smooth and what is this rough, right? So it is basically nature of surface. It is basically nature of surface. But in case of smooth surface, see if you see the surface molecules, If you see the surface molecules, the irregularities will be less. The irregularities of surface molecule is less on surface of ice. Okay. On surface of earth, the irregularities will be more. So it seems to be rough. It seems to be rough. Okay. So in case of ice, it is smooth, the irregularities will be less. In case of earth, the irregularities will be more. It is what, like a rough surface, right? So when you are walking on surface of earth, when you are walking on surface of earth, right? So you are feeling comfort. So what I am saying is, when you are walking on surface of earth, not only surface of earth, on any surface of earth, you are applying some force on that surface, right? So it has its own direction. The applied force has its own direction. According to Newton's third law of motion, force is not single in this universe. Force always occurs pair. Okay, right? So when you are applying some force on the surface, that surface also applies certain amount of force, right? That is when the body is at rest. Morning, I mean, in the last class also I told you, right? So when you are standing on surface of earth, two forces are acting. One is gravitational force, another one is normal force. These are the two forces when the body is at rest. When the body is at rest, when the person is at rest. But when the person is moving, then what will happen? He is applying some force either biologically or externally. That is not matter here. But some horizontal force is applying there. When certain amount of horizontal force is applied, opposite to that, some other force will come into the picture. That is simply called as frictional force or friction. Okay. So you have to imagine two examples at a time to understand the role of friction and the reason for arising of frictional force. Okay. One thing is, suppose you take a person when he is at rest. He is standing, but he is at rest, no motion. In this time, I am talking only two forces. One is gravitational force, another one is normal force. But when he is trying to move horizontally, right? So in horizontal direction, one force is acting, right? Opposite to that, some other force will come into the picture. So that is, I am saying, frictional force. Okay, right? So now I explained you what is frictional force with live examples, right? Because sometimes we may stand on the surface of earth, sometimes we are walking. So the frictional force will come into the action when you are walking, right? But it also will play even when you are standing, that we will discuss. So which is called as static friction, and when you are walking it is called as kinetic friction. That and all we will discuss in this class. Okay, right? See this. A body of mass m at rest on a horizontal table, right? The force of gravity is cancelled by the normal reaction. The force of gravity is cancelled by the normal reaction force of the table. Next, now suppose a force capital F is applied horizontally to the body. Now suppose a force capital F is applied horizontally to the body. Okay, full stop. We know from experience, right? So we know from experience that a small applied force may not be enough to move the body. Am I correct here, ma? You cross check yourself. A body of mass m at rest on a horizontal table. The force of gravity is cancelled by the normal reaction force of the table. Right? Full stop. Now, suppose a force capital F is applied horizontally to the body. We know that from experience, right? From observation, from experience, that a small applied force may not be enough to move the body. So we need a larger force. A small applied force may not be enough to move the body. Okay, right? Next, we know from experience that a small applied force may not be enough to move the body, but Okay, here itself we have to discuss. If the applied force F were the only external force, on the body, but if the applied force capital F were the only external force on the body, then what will happen? It must move with an acceleration F by m, right? So, to understand this statement, to understand this sentence, we need to keep in mind what is Newton's second law of motion, right? From Newton's second law of motion, F is equal to ma, no? So, A is equal to F by m. A is equal to F by m. So, here when the applied force were the only external force on the body, no other force, then what will happen? A is equal to F by m. A is equal to F by m. But in practical, acceleration is small. Acceleration is small. So, you can calculate by taking a certain amount of mass and by applying certain amount of force, then you can calculate what is the acceleration value, right? That is A is equal to F by m, right? So, in practical, this acceleration value is less than the practical value, however small, okay, right? So, when it is small, so what may be the reason? What may be the reason, right? So, clearly that the body remains at rest, because some other force comes into play in the horizontal direction and opposes the applied force, resulting in zero net force on the body, okay, right? So, from here to here, so you can see the light from here to here, we are in a discussion about the body in motion and body at rest. The point is when a body is in motion and only external force is acting on it, the acceleration must be equal to F by m. But in practical, it is small. In practical, it is small. So, what is the reason for smaller value of acceleration? Okay, right. The answer will be some other force is acting. Opposite to the direction of applied force. That we are calling it as frictional force. Okay, right. Next, clearly the body remains at rest. Because some other force comes into play in the horizontal direction. Clearly, the body remains at rest because some other force comes into play in the horizontal direction and opposes the applied force. So, here he is talking about when the body is at rest, you know what is meant by rest? When the position of your body is not changing with respect to time and surroundings. Okay, when the position of a body is not changing with respect to surroundings and time, then we can say that the body is at rest. Okay, the body is at when the position of a body is not changing, with respect to surroundings and time, okay, then you can say that the body is at rest. Okay, right. So, when the body is at rest, how it is possible for the body doesn't changes its position with respect to time and surroundings? The answer will be the force which comes into play in the horizontal direction and opposes the applied force, right? So, here two things, one is applied force, another one is frictional force, right, resulting in zero net force on the body. When the net force is zero on the body will not move, right? So, two things we are satisfying which are related to our daily life. When the body is in motion, obviously it covers certain displacement, then it is going to maintain some velocity, then finally it leads to having certain amount of acceleration. That acceleration should be A is equal to F by m, but in practical it is not equal to F by m, it is smaller value because some other force is acting opposite to the applied force. That is one thing. Another thing is, when the body is at rest, why it is not changing its position with respect to surroundings and time means opposite to the applied force. In which direction the force is applying? Some other force is applying opposite to the applied force. Then finally the net force on the body is zero, the body will be in the state of rest. Okay, right. Next, you can see the pictures here. So this is the body. Some force is applying, right, in opposite direction. Some other force is applying, that is frictional force, right. See here. So here the body is in motion. You can see this direction. Here the body is in motion. So this is the applied force, and here it is Fk. It is Fs. It is Fk, right. Fs means it is the static frictional force. Fs is the static frictional force. Fk means it is a kinetic friction. Okay, right. So I will tell you now here, the force Fs parallel to the surface of the body. The force Fs parallel to the surface of the body in contact with the table is known as frictional force, or simply friction, that you can also write in the bracket static friction. Okay. So please try to understand, this is the situation when the body is in the state of rest. When the body is in the state of rest. Even though the body is in the state of rest, we have to understand, we have to discuss how it is possible to get the state of rest. So without movement. Okay. So the applied force is equal to the frictional force opposes to the applied force. Then the role of this frictional, when the role of this applied force cancelled by the frictional force, cancelled by the frictional force, then the body will continue in the state of rest. Okay. Then what will happen finally? It will not change its position with respect to surroundings and time. Then as usually we are saying that it is at rest. Okay. This is all about when the body is at rest. Suppose the body is in motion. How it is possible to provide the motion? When the static friction is equal to applied force, right. So static frictional force is the frictional force applied on the body when the two surfaces, so the bottom surface of a body and the top surface, both are at rest. Okay, right. When the magnitude of applied force is increasing with respect to time, when the magnitude of applied force is increasing with respect to time. Okay. When the magnitude of applied force is increasing with respect to time, then what will happen? Okay, at a particular moment, at particular instant of time, the body will try to move, because when the force of when the applied force magnitude is increasing with respect to time, so this frictional force is there now, this static friction is there now. So this static friction also has its own magnitude. So when the applied force is greater than the magnitude of static frictional force, when the applied force is greater than the magnitude of static frictional force, then what will happen? The body will get into the motion. When the body will get into the motion, also frictional force is acting. That frictional force is called as kinetic friction. That frictional force is called as kinetic friction. Okay. So when the body is at rest, also frictional force is acting here, that is static friction, which makes the body to be at rest. When the applied force is greater than the value of frictional force, also body will come into the motion, but frictional force continues to act. But we can say experimentally, through the observations, we can say that Fs is greater than Fk. Fs is greater than Fk. Okay, that is. Next, static friction does not exist. Static friction doesn't exist by itself. Okay, when there is no applied force, there is no static friction. It comes into play when there is applied force. Okay, so please try to understand these three lines of information. Here you are getting the concept how the static friction force starts to act and starts to play a role. Okay, static friction doesn't exist by itself. When there is no applied force, there is no static friction. It comes into play when there is applied force. When there is applied force. Okay, that is. So he is talking about static friction here. Next, you can say that applied force is applied force is directly proportional to the static friction. Right. This is up to certain limit. This is up to after the limit, the situation will be different. Okay. See, for example, there is a body, we are increasing the applied force, we are increasing the magnitude of applied force. What will happen? The magnitude of static frictional force also starts to increase. So when you are increasing the applied force, the magnitude of static frictional force also increasing. Okay. So when it attains certain value, when it attains certain value. Suppose for example, it is what 5 newtons, the body is not moving. Suppose the magnitude of static frictional force is 8 newtons, just imagine. It will be 6 newtons, body will not move. It will be 7 newtons, body will not move. When the applied force is 8 newtons and the static frictional force is also 8 newtons, the body is just ready to move but not moving, still at rest. When the applied force is greater than the static frictional force, for example, capital F is equal to 9 newtons, it is 8 newtons, then what will happen? The body is moving continuously. The body is moving continuously. Okay, that is the role of static friction regarding the movement of a body. Regarding the movement of a body. Okay, right. Next, here up to certain limit, right? Applied force is directly proportional to the static frictional force. Okay, right. Up to certain limit. Suppose if applied force is equal to Fs, applied force is equal to Fs, keeping the body at rest. Keeping the body at rest. Hence, it is called static friction. Hence, it is called static friction. Okay, right. Static friction opposes impending motion. Static friction opposes impending motion. What is motion we know, but what is the meaning of the word impending? What is the meaning of the word impending? That is important. Okay, right. So here we had explanation. See this. Impending motion means motion that would take place. Impending motion mean motion that would take place under the applied force. Impending motion mean motion that would take place under the applied force if friction were absent. If friction were absent, right? When there is no friction, the motion that would take place under the applied force is called as impending motion. Okay, right. Next, as the applied force exceeds certain limit, as the applied force exceeds certain limit, limiting value of static friction is independent of area of contact and varies with the normal force. As the applied force exceeds certain limit, as the applied force, listen carefully ma, observe, when I am reading the sentence you have to observe, right? As the applied force exceeds a certain limit, limiting value of static friction. So limiting value of static friction is nothing but the maximum value of static friction. Just now I told you one example here. When the applied force is 5 newtons, suppose if it is 8 newtons, it is 6 newtons, it is also 8, it is like that. Okay, what I am saying is the magnitude of static frictional force changes with respect to applied force, but there is certain maximum value. When the applied force exceeds the maximum value of static friction, which is called as limiting friction, then the body will get into the motion. Okay, right. So similarly here, that only he is saying here, but they told one more point. Maximum value of static friction, that is limiting value of static friction, is independent of area of contact and changes with the normal force. Why it is changing with the normal force means, see this relation, Fs maximum is equal to mu s into n. It is the static friction, it is the normal force. Okay, so the product of these two things, so which we can also call it as one of the law of friction, right? So F is directly proportional to n, then F is equal to mu s into n. Okay, mu s is the constant of proportionality. Depending upon the nature of surfaces in contact. Mu s is the constant of proportionality depending upon the nature of surfaces in contact. So here he is talking about coefficient of static friction. Okay, right. So this coefficient of static friction depends upon the nature of surfaces in contact, nature of surfaces in contact, okay. And you can also write this, Fs is less than or equal to mu s into n, Fs is less than or equal to mu s into n, okay. So from this discussion, you have to understand what is the relation between applied force and static frictional force, right. So if you understood that, you can easily understand why we are writing this one and why we are writing this one, right. This one is okay, it is from law of friction, that is frictional force is directly proportional to the normal force. When you are removing the frictional, when you are removing the proportional constant, you can write it as mu into n. F is equal to mu into n. We are talking about static frictional force, that's why we added one symbol, that is S here and there. It is static friction and coefficient of static friction, okay. Mu s is the constant of proportionality depending upon the nature of surfaces in contact, okay. Fs is less than or equal to mu s into n, okay. Next, if the applied force capital F, if the applied force capital F exceeds, if the applied force capital F exceeds, the body begins to slide on the surface. That's this point already I told you when I am explaining the situation, but he has written once again, if the applied force exceeds Fs maximum, the body begins to slide on the surface. The body begins to slide on the surface, okay. Next, relative motion has started, the frictional force decreases from the static maximum value, see here, relative motion has started. Relative motion means the motion of one surface with respect to another surface has started. When the frictional force decreases from the maximum value of static friction, that is static maximum value. I already told you, right, in the previous example when I am showing the pictures, right. So first the applied force, when the applied force starts to act, then frictional force starts to act, that is called as static friction. When you are increasing the magnitude of applied force, magnitude of frictional force also increasing, but that is up to certain value. When the maximum value of static friction is present, when it will be less than the applied force, then what will happen? The body will start to move. So which is simply we are calling it as relative motion has started. Relative motion has started, okay, that is right. Next, see this afterwards, next continuation to that frictional force that opposes relative motion, frictional force that opposes relative motion between surfaces in contact, is called as kinetic or sliding friction, right. So here he is defining the next continuation to this topic, that is kinetic friction. So till now we focused on static friction, but now we are going to start to discuss about kinetic or sliding friction. So what is kinetic friction? The frictional force that opposes relative motion, between surfaces in contact, is called kinetic or sliding friction, Next, kinetic friction is independent of area of contact. Nearly independent of velocity. Kinetic friction is independent of area of contact, nearly independent of velocity, okay, right. So Fk is equal to mu k into n, Kinetic friction is independent of area of contact, nearly independent of velocity. So Fk is equal to mu k into n, and this line is important So like these things we must remember while solving the problems related to NEET and mains. We need these things. So these things will come directly like MCQs, multiple choice questions, right. Otherwise while solving the problems we need this information, okay. Kinetic friction is independent of area of contact, nearly independent of velocity also, right? Then you can write here Fk is equal to mu k into n. Next, mu k is equal to coefficient of kinetic friction, depends only on the surfaces in contact. See here, coefficient of kinetic friction depends only on the surfaces in contact. Mu k is less than mu s. Mu k is less than this point, already I told you in the same class, but here he has written clearly mu k is less than mu s. Okay. Next, when the relative motion has started, the acceleration of the body according to the second law is F minus Fk by m. It is what? It is including the frictional force. Including the frictional force. In the absence of friction, A is equal to F by m. In the presence of friction, we need to write F is equal to F minus Fk by m. Okay. Next, for a body moving with constant velocity, for a body moving with constant velocity, when a body is moving with constant velocity, suppose if F is equal to Fk, F is equal to Fk, what will happen? If applied force on the body is removed, if applied force on the body is removed, then acceleration, if the applied force on the body is removed, then acceleration A is equal to, suppose if applied force is 0, only frictional force is present, that is kinetic friction, that is kinetic friction. Don't go for starting it is only static friction and applied force. When the body once get into the motion, suppose if applied force is 0, then what about the acceleration? It is minus Fk by m, minus Fk by m. Okay, right. So, and one more very important thing is here, this is the statement we have to keep in mind. Laws of friction are empirical, so they do not have practical existence, but approximately true. Based on our experience, based on our observations, we derived and we have written the laws of friction. Okay, laws of friction are empirical. Okay, laws of friction are empirical. See here, thus, okay, when the two bodies are in contact, each experiences, thus when two bodies are in contact, each experiences a contact force by other. Thus, when the two bodies are in contact, each experiences a contact force, okay, each experiences a contact force by other. So, when two bodies are in contact, okay, right. Next, frictional force opposes the relative motion between two surfaces in contact with each other. Frictional force opposes the relative motion between two surfaces in contact with each other. Okay, afterwards. So, these are the important points we have to keep in mind. Next one is, consider a box lying. So, it is the lively example. I will read this information, you just observe carefully. After completion of that, I will go to the explanation. A box lying in the compartment of a train. The train is in motion. The train is in motion, so it is accelerating. If the box is stationary relative to the train, if the box is stationary relative to the train, it is in fact acceleration along with the train. So, the acceleration of the box is equal to acceleration of the train. Then there is no movement for the box. Here itself, the conceivable force in horizontal direction is frictional force, right? When a box is lying in the compartment of a train, the box is in the state of rest, means the acceleration of the box is equal to acceleration of the train. Next, if there is no friction, the box would remain at its initial position due to the inertia, right? So, the static friction provides the same acceleration to the box of the train, keeping stationary relative to the train. So, initially it is static friction, right? Even though the box is wholly is not moving, here our discussion is not the motion of the box. That's why here the major role played by the static friction only. Okay, right. So, this is all about the class. We continue this topic with in the next class.